A population of bacteria is growing according to the equation P of t equals 1000 times e raised to the power of 0.12 t, where P of t is the population and t is the time in hours. We want to estimate when the population will reach 5,000 and round our answer to the nearest tenths. We will be solving this type of problem using logarithms very soon, but for right now we're going to solve this problem using the graphing calculator. We'll use the table feature as well as the graphing feature to solve this problem. So we're given this equation here that tells us the population of the bacteria at t hours. And we want to know when the population, or P of t, reaches 5,000. So we're trying to solve the equation 5,000 equals 1,000 times e raised to the power of 0.12 t. Let's start by entering the function into our graphing calculator. So we're going to press y equals, clear out any old functions. So we'll just press clear, clear, go back up to y1 and type in the population function. So we'll have 1,000. And then for e, we press second ln. Our exponent is 0.12 times t, which we'll just use x. And now let's go to our table set by pressing second window. Let's go ahead and start the table at 0 and increase the values by 1. So now if we go to our table by pressing second graph, we can get an idea of when the population will reach 5,000. So if we scroll down, notice how it's somewhere between 13 and 14 hours. To be more precise, we could go back to the table set and start the table at 13 this time and make the change in table tenths, so 0.1, and narrow down our estimate to the tenths. So now if we press second graph, so here we can see that the value of x, or in this case t, closest to 5,000 to the nearest tenth would be 13.4. Let's also verify this graphically though. So if we go back to y equals, go down to y2 and type in 5,000, we could also find the intersection of these two functions, and the x-coordinate would be the value of t where the population reaches 5,000. But before we do this, we do have to adjust the window. So we'll press the window key. We know the solution is about 13.4, so we'll leave the x-min at -2. We'll change the x-max to, let's say, 18. And then we know the y-maximum has to be at least 5,000, so let's set the y-minimum to -300 and change the y-max to 6,000. Now if we press graph, there's the exponential function that models the population, and here's a horizontal line, y equals 5,000. The x-coordinate of this point of intersection would be the time at which the population reaches 5,000. So now we'll press second trace for calculation, and then select option 5 for intersection, and then press enter 3 times. 1, 2, 3. And again, rounding to the nearest tenths, which we're asked to do, the time would be approximately 13.4 hours. We will solve the same problem again using logarithms after a few more lessons.